Hey, hi, and welcome back. So in this video, we are going to complete the component placement of 4 sections. The first one is microcontroller section. Then the second one is user input switch section. Then the third one is a reset section. And in the end, the last one is RGB LED section. Okay. So we will complete the component placement of these 4 sections in this video. Alright. Now let's start with this video. So we are done with all the components of a motor driver section. Now let's start with the microcontroller section. So this is basically the microcontroller section, and let's grab the controller now and let's place the controller. Now here the question comes, what should be the orientation of the controller? Okay. So that whether the controller should be placed like this, okay, or like this or like this. Okay. So that decision you have to take. And how you will take that decision, I will tell you. So first of all, I will click on rat nest. You have to make sure that where the most of the connections are going. Okay. And accordingly, you have to choose the orientation of, the controller. You can see here the potentiometer connection is here. Then the switch connections are actually directly, you will not get this at this moment because a lot of components of this switch is actually placed here. Okay. But you have to make sure that what will be the suitable position for this particular controller, which will make the connections to its peripheral direct. Okay. So we have to reduce the complexity of the layout. Okay. Like for example, if the connections from this RGB LED towards this controller is direct from this side, then the preferred orientation, for this RGB LED will be this one. Okay. The notch should be on this side, or pin number 1 should be this side. But if this RGB LED is placed at this location, then a preferred orientation for this particular controller will be somewhat like this. Okay. Like this. So here there is a dot now. This is basically the pin number 1. And from here, we can actually directly connect to the RGB LED. So likewise, you have to check what pins are going to make the direct connection towards the peripheral which are connected around the microcontroller. And based on that, you have to choose the appropriate orientation. Okay. Also, one more thing that I want to tell you here. Sometimes it will happen while placing or while selecting the orientation of this controller, you will find that none of the orientation is actually helping you to resolve the connections or to make the layout simplified. So in that case, what you can do, now we know that the position of this particular preset is fixed. Okay. So this preset will be here. These 2 switches will be here. So what we can do, we can actually choose the analog pin from this controller on this side. Okay. We can choose the digital pin for these switches or the user input switch from this side. Okay. So likewise, you can do the changes in the schematic while you are creating the layout. Okay. So this is basically very common method, and most of the layout design engineer are going to, do the changes in the schematic while creating the layout. But it's obvious they are going to take the permission of schematic design engineer. If the person has created the schematic, some other person has created the schematic, then he's going to inform the team that he will tell that this particular, component is placed here. So I feel like this side, the pins on this side of this controller are more suitable for this particular user input switch. Okay. So accordingly, he will tell the team, and he will take the permission, or they are going to mutually decide whether we select the pin from this side for the user input switch or not. Okay. So likewise, while creating the layout, there will be multiple changes, okay, in the schematic, because most of the time we have to resolve the connections in the layout, okay, in order to reduce the complexity of the layout. So now that we have fixed the position, and this is actually going to be the orientation of the controller in our case. Okay. Now let's grab the components for this user input switch now. So for that, I will go here. So again, we have to choose, the right orientation. We have to check which orientation of the component will be suitable. For example, here if you see all the connections, just a second. So all the connections are actually direct. So this particular orientation is actually more suitable for the user input switch. And always remember, whenever you are doing the layout or whenever you are placing the components of a particular section, then all the components which are there in that section should be placed near the main IC or the main component. Okay. For example, this is power supply section. This is power supply IC. So we have placed all the components of this, power supply section near this IC. In the same way, this is user input switch. The resistors and pull-up resistor and decoupling capacitor for this user input switch will be placed here. Okay. So likewise, you have to place the component because that will actually reduce the complexity, and it will help you to create the layout, okay, in a much better way. So these were the components of this user input switch. Now let's take the components of this reset section. Alright, so we are done with the components of reset section. Now let's get this capacitor which is connected between the DTR pin and the reset pin. Okay, so let me select this capacitor now, and this is that capacitor. So this particular capacitor you can actually place you can also place this capacitor here near this debugger, because you can see this reset pin is actually more close to this debugger. But you can also place this capacitor near this this reset pin, or you can also place it here. So wherever you want, as per the availability of space, you can actually place the component. Now in our layout, I have actually placed it here like this. So I'm just going to place somewhere here. So you can see in this layout, this is basically C14, and I have placed it here. So I will just change the orientation. Okay. So I already told you, to create the layout or to place the component, it's going to take a lot of time. Now that I'm creating the video, so I have to do all the things quickly. And now let's place these decoupling capacitor near the IC. We have already discussed the purpose of these all decoupling capacitor. So one by one, we are going to place all these decoupling capacitor near each and every VCC pin. So first of all, let's collect these capacitor, and later we will place these capacitor near the IC. Alright, so we got all the decoupling capacitor, and you already know the purpose of these decoupling capacitor. We need to place these capacitor near each and every VCC pin of the controller. Okay, so whatever noise or high frequency noise which will be created by this IC during its operation, those noise will be actually decoupled by these capacitor towards the ground. Okay, and that noise will actually it will not go towards rest of the component, because these capacitors will be actually placed on 5-volt line. So there will be a lot of switches inside the controller, and when the controller is working, for example, if you are working on an interface at a high speed, there is a high probability that there will be noise on plus 5-volt pin. Okay, because of the switching of the internal components or the internal transistors or MOSFETs which are present inside the controller. So because of that, there will be noise, high frequency noise on this 5-volt line, and it's our responsibility to remove that noise, and we have to decouple that noise towards the ground with the help of capacitor. So we have to place these capacitor as close as possible to these pins of this controller. So this is basically the 5-volt line. So I will just check which are the pins of 5-volt. So this is basically the first pins, this is second, and then this is the third pin. Alright, so now let's place the capacitor one by one. So I will get this one, I will rotate this one, and I will place it here like this. So the noise which will be there on this pin, it will be decoupled by this capacitor, and then the noise which will be there on this pin, it will be decoupled with the help of this capacitor. After that, let's place this capacitor near the another VCC pin. So this is basically another VCC pin somewhere here. So you can see this is that pin. So I'm just going to place this capacitor in this orientation or in this way near this capacitor. So it's not like you can also change the orientation. You can place the capacitor like this also, but it will take little more space, and it's going to cover, more number of pins of this controller. So this orientation is actually more appropriate. That's the reason I'm placing these components or these capacitors in this manner, okay? But you just have to place these capacitor near to IC. It's not like you can place it here, okay? So it's not worth, okay, placing this capacitor here. It's better you place this capacitor near this IC, because quickly the noise or the switching noise that will be produced by this IC, it will be decoupled by this capacitor towards the ground, and it will not reach towards the rest of the components. All right. And after that, now let's get this capacitor of 22 microfarad and let's place it here. Now, I already told you that this particular capacitor is basically a kind of bulk capacitor, and this capacitor is going to fulfill the current requirement of this IC. So we have to place it near the power line. So from here, 5 volt will come like this. So let me select the 5 volt line first. So from here the 5 volt will come. Okay, so from here the 5 volt will come, and then we have to pass that 5 volt through this capacitor like this, and we have to just make sure that this particular capacitor should be placed on the entry point of the 5 volt line, which will go towards this IC. Okay, so this is basically the entry point. From here it's going to come. So we should place this capacitor for at the entry point. Okay, so whenever there will be a sudden requirement of the current for this particular IC, it will be fulfilled by this particular capacitor. Okay, so again you have to make sure that this capacitor should be as close as to this particular IC. Okay, so we are done with all the capacitors which are connected around the VCC pin of this IC. Now let's get this crystal and let's place this crystal. Now if you see the pins of this crystal, let me check where the pins of crystals are. So you can see these are actually the pins of the crystal. So it's better we place this crystal near these pins. Okay, so you can place the crystal in any manner. It's up to you. You just have to make sure that you place the crystal a little bit closer to this IC. And if you see here, I have actually placed the crystal in the 45-degree angle, and I have done this intentionally because this is actually going to it's going to save a lot of space on the PCB. Although we have a lot of space on the PCB, but with this arrangement we are actually going to save more space on the PCB. Okay, so that's why I have placed this crystal in this fashion. All right, so in the same way I will do that here also. So you have to click on properties, and later from here you can actually change the angle of the component. So here I will write 45-degree, and after that I will click on apply and then OK, and later I will click on rack nest. So you can see from here there is a straight connection. So let me select show option here. So you can see from here there is a straight connection, and again from here there is a straight connection. So I will place this crystal properly, and later these are the decoupling capacitor of this crystal, and I'm going to place these capacitor near the crystal. And again let's place these capacitors again with the angle of 45-degree. This is actually not mandatory, but just to make the layout little bit nicer, I'm actually doing this. You always have to make sure that first of all your priority should be the component placement, and then the second priority should be the looks. Okay, so the first priority should be the component placement. We should place the component at the appropriate location, and later we can think about how exactly the layout is looking. Okay, so in order to make the layout, you can place the components accordingly. So I'm just going to place these capacitors, decoupling capacitor near this crystal, and you can see here there is an overlap. So I'm just going to move these capacitors like this. I will group them, and later I will place them here. All right, so again they are actually near to this IC only, and I will just move this capacitor like this. All right, so these minor changes you can do later. So we are done with all the components which are present in the Atmega 328 microcontroller section. Now let's place the components of RGB LED section. So we already placed the RGB LED, and now let's grab these two resistors, these three resistors. Now if you see here, I have actually placed these current limiting resistor of this RGB LED near to this RGB LED. The reason is these resistors are actually part of this section. So it's better we place these resistors near to this RGB LED. But it's nothing like you should place these resistors here only. You can also place the resistors near this, controller, okay? Even if you place these resistors here, it's completely fine. There won't be any kind of problem, okay? But as I told you, generally we try to place, all the components of that particular section near the main component of that section. So here the main component is RGB LED. So that's why I have placed these resistors here near the RGB LED. Alright, so we are done with the component placement of all the 4 sections. Now we are just left with the 7-segment display section. So we will complete the component placement of that particular section in next video. Okay. Alright, so now I will see you in the next video.